Welcome to Ask and Learn.
In this exercise, we're going to be talking about orbital speed and escape speed. So I'm briefly going to review the terms before we actually dive into the exercise. So consider that we have a planet and a particle, another body that is orbiting the planet with a radius of orbit of r. Okay, this is the distance between the center of the planet and the orbit. The speed of a body so that it makes a circular trajectory around the planet is equal to g here is Newton's gravitational constant, times the mass of the planet divided by r. Also, given that a body is located at a certain distance r from a planet, the speed it needs in order to escape the orbit of the planet is equal to 2gm divided by r. Okay, the square root of 2gm divided by r. So now we can actually go on to the exercise. So what we have is an explorer that is is approaching Mars, actually. And it approaches Mars in the trajectory shown here in green. And at point A, the speed of this explorer is 10 megameters per hour. Okay, Mars is the red circle here. And the mass of Mars is equal to 0.1074 times the mass of the Earth. And we know that the mass of the Earth is equal to 5.98 times 10 to the 24 kilograms. And our goals are twofold. First, we need to find what is R0 such that R0 is the radius of the orbit of shown here in blue in the figure. That is the orbit that this explorer would perform around Mars if its velocity decreased to a speed that would allow an orbit to occur. So we want to find R0. So basically what we need is to realize that at the point shown here in the figure, notice that the green trajectory is the trajectory of the explorer, and at point A, the explorer reaches its closest point to Mars. So actually, this means that the velocity, the speed that the explorer has at this point, is the escape speed of Mars at the distance r0. Okay, so basically we have that v is equal to the square root of 2gm divided by r, 0. Now we want to find r0, and that's 2gm divided by v squared. So this is 2 times 6.67 times 10 to the minus 11 newtons meters squared per kilogram squared times the mass. That's actually, I'm not gonna write this here because I'm running out of space, so I'm gonna write it down here. So I have 2 times 6.67 times 10 to the minus 11th newtons meters squared per kilogram squared times the mass. That's 0.1074 times the mass of the Earth, which is 5.98 times 10 to the 24 kilograms, divided by V. Now remember that V is 10 megameters, so this is 10 times 10 to the 6th, so that's 10 to the 7th meters per hour. Now 1 hour has 3,600 seconds, so this is equal to 2.78 times 10 to the 3rd meters per second. So this is 2.78 times 10 to the 3rd meter per second. squared. So R0 is equal to 1.1 times 10 to the 7th meters. So this is the radius of the trajectory. Then we need to find what is the speed of the orbit that has a radius R0. So this is, according to what I said before, this is the square root of gm divided by R0. So this is the square root of 6.67 times 10 to the minus 11 meters, newtons meter squared divided by kilogram squared times the mass. That's 0.1074 times 5.98 times 10 to the 24th kilograms divided by 1.1 times 10 to the 7th meters. So VA is equal to 1.97 times 10 to the 3rd meters per second. Okay, and this concludes our exercise.